This is tutorial question number 2. A 4-meter long curved gate is located in the side of a reservoir containing water as shown in figure 2. Determine the magnitude of the horizontal and vertical component of the force of the water on the gate. Will this force pass through point A? Explain about it. So in this situation, we have a quarter circle gate like this. However, the water surface is on this level. So in previous question, we only have a water level which is here, right? It is passed through the point A, but now in this question, the water is far above the gate here. So we could start to analyze this diagram. So because we only need to analyze what happened on this quarter circle gate, so we create the projection area of this gate, so it will become like this one. So and then we know that because it is quarter circle, so the radius here is 3 meter, so means that the height here is also 3 meter. So and then from the 9 meter here, the 6 meter of water is actually occur above the gate here. We could calculate the horizontal force by using this equation, rho g HCA, and then the HCA here should be 3 over 2 plus 6 meter. So means that we draw the centroid here, so and then the distance of this centroid is 3 divided by 2, and then we need to add with this 6 meter deep of water. So the area is 3 times 4, so we get it is 882.9 kilonewton. To determine the YR, so this is the equation. So we have it is 7.6 meter from the free surface. Please bear in mind the YR here is the distance from the free surface point here to the resultant, the horizontal force here. So please bear in mind that the YR is actually need to be start at free surface. Now we could calculate the vertical force. The equation for vertical force is rho, g, and volume. And then in this situation, we need to calculate this volume. So we have a quarter circle area here. So, and then we need to add with the volume until the free surface. So now the calculation must be the rectangular volume and the quarter circle volume. So you may calculate like this one, and the magnitude of the vertical force is 983.6 kilonewton. So and then we could determine the location where the vertical force acts. However, because this shape is actually not a common shape, so it is we don't have a specific equation to calculate the XR for this shape. However, from the idea of moment, we could split the phenomenon here by calculating the moment of rectangular and its vertical force plus the quarter circle area with its vertical force here. So and then we know that the distance of XR1 here means the centroid of this rectangular by dividing this length into 2. So and then we could determine the centroid of the quarter circle here by using the equation of 4r over 3 pi. So and then the equilibrium of moment can be written like this one, Fv, the total force here multiplied with the XR is equal to force only, the vertical force only for the rectangular area, plus multiply with the distance, and then plus the vertical force only for the quarter circle here times the XR2 here, mean the distance of the centroid from the origin here. So we calculate we substitute the value. So and then the only unknown parameter here is the value of xr. So and then we could calculate the value of xr is equal to 1.436 meter from the origin. So please bear in mind that the origin here need to be the same point for all the diagram here. So and then the question, will this resultant force pass through point A? So point A here is the center point of the circle here. So the answer is yes. So it will. So we could prove it by this calculation. So let's say we have a quarter circle like this one, and this is the horizontal force and this is the vertical force, and then we could rearrange the force by like this. So this is the horizontal and this is the vertical, and then we could calculate the resultant force here. So according to this triangle, so we could calculate the tangent theta, I mean the tangent at this one, the theta at this angle. So and then it is equal to 48.088 degree. So and then same triangle can be written by using the distance of x and y. So x here is the distance from here to here. So and then y is the distance from here to here. So and then the value of y is known. It is equal to 1.6. So here please be careful, because the y 1.6 here is actually comes from the calculation of yr. So the yr here is 7.6, but the 7.6 is actually from the free surface to the horizontal force. So means that we only need the distance from the origin here. So we need to deduct with 6 meters here. So it will become 1.6. So when we substitute the value here, so we could get the x is 1.436 meter. So if we compare this result with the idea from the moment here, so we get the same amount, the same value of xr. So means that even though the water is above the center point of this circle, so the resultant force that acts on this quarter circle shaped gate here is passed through the point A. So the point A here means the origin of the circle. Above mentioned calculation shows that the resultant force that acts quarter circle curved plane is passed through the origin of the circle.